everyone, welcome to gemchem. Now today's video will be on alkenes part 1. Here we will discuss about the structures of alkenes. Now before starting, if you have not watched alkene part 1 and part 2, do watch it. It will be helpful. The link will be given in the description box. Now let us start. Now what are alkenes? We already know alkenes are hydrocarbons and they contain one or more carbon-carbon double bonds, sometimes called olefins, and ethylene is the simplest alkene. Now what is ethylene? We know ethylene is two carbon compound with one double bond in between and two hydrogens. This is a molecule just placed in the plane of this page, right? And if this bond by holding this two carbon is rotated and two hydrogens are taken near us and these two hydrogens goes below the plane, then the structure looks like this. So we can write these two hydrogens by dash and these two hydrogens by wedge as they are towards us. Now let us see next part. Now what are the bonding orbitals which bond in alkene? We have already discussed these things in atomic orbital video. If you have not watched it, please do watch it. I will give the link in the description box. Now see this one. Again I am telling this is a p orbital and this is also a p orbital. These two p orbitals basically overlaps to form the pi bond. Okay, and there are three sp2 hybridized orbital. That is this one sp2, this one sp2, and this one is also sp2. So these three orbitals are hybridized orbitals. Two sp2 hybrid orbitals forms bonds with hydrogen, whereas another sp2 hybridized orbital forms a sigma bond with another carbon. Sigma bond is formed by interaction of two sp2 bonds. We have already discussed that hybridized orbital are more strong in bond formation than the normal orbitals. So the sigma bond is stronger than the pi orbitals, pi bond actually. Now we will start with the general discussion on few facts. Okay, now let us start. Now facts are that S character, that is amount of S orbital character present in the hybridized orbital is most for sp, because it is formed by the combination of one s and one p, 50-50, whereas in case of sp2 it is less because it is consists of one s orbital and two p orbitals, and similarly for sp3 the S character decreases. So this is the order of S character, whereas for p character this is the order of p character, because here the percentage of p is greater. Now greater the S character, shorter will be the bond length. As the bond becomes stronger, the two atoms are closer to each other, their bond length decreases. Whereas if greater p character, then greater will be the bond length. So we can write S character directly proportional to bond angle, and it can be also written as S character is inversely proportional to bond length, 1 by bond length. And we have to know that bond angle decreases with increase in p character. As p character increases, bond angle decreases, whereas as S character increases, bond angle increases. So this part of this page is much important, greater important. This will be required for whole organic chemistry knowledge. So let us see. Now see, as I have told you, as hybridization increases, as p character increases, the bond angle decreases, right? So here the p character is least, that is 50%, so it is 180 degree, whereas here p character is more, 120, and for sp3 hybridization it is 109 degree 28 seconds. Now see, we will discuss two questions based on the facts which we have known. Now this question tells that the bond length, that is the CC bond length, this bond length is greater in case of this alkane, whereas lesser in case of this alkene. So why this is so, we have to understand. Now see, first thing first, if we consider the hybridization first, this carbon is sp3 hybridized, right? And this carbon is sp2 hybridized. So this bond is formed by sp3 and sp2 carbon, whereas this bond is formed by both sp3 and sp3 carbon, right? So bond formation between sp3 carbon. Now we have already seen that this sp2 hybridized orbital has more s character, right? More s character means what? More s character means that the bond length will be shorter, as it is inversely proportional to s character, right? Bond length shorter, so this bond is shorter. Okay, but we have also another explanation. The alkene is stabilized by hyperconjugation. Now if we consider the alkene given in the question paper as this one in spread form, now a proton can be released from this to form hyperconjugative structure. Okay, one proton releases to give CH2, H plus is the proton released, and the double bond here, and here is a carbon ion. That is what happens is, here from here the proton is being released by giving the negative charge here. The negative charge comes here and this is donated here, and this double bond is pushed back. So we can see from here that this bond, particularly carbon-carbon bond in discussion, is having a partial double bond character. So we know that double bonds have lesser bond length. So from here also we can say that the carbon-carbon bond length is short because of presence of partial double bond character, which can be shown using hyperconjugative effect. So the question given here requires two reasons to be mentioned. One is about hybridization and overlap, and second is about hyperconjugative effect, right? Now we will see another question. See our next question. Here it is asked to tell why the bond length of carbon-hydrogen bond present here is much lesser for the cyclopropane than for the propane itself. So what is the reason? Here we will deal with the fact of bond angle, right? So we know that the bond angle decreases with increase in p character. This is known. Now we have to see these three carbons are basically sp3 hybridized carbon. So sp3 hybridized carbon, we know what is the bond angle. It is 109 degree 28 seconds, right? Now here actually the bond angle is reduced to 60 degree. So much greater strain. So when bond angle is decreased, that is for decrease in the bond angle, we require an increase in the p character. So for which bond the angle is being talked of? It is the carbon-carbon bond. So these carbon-carbon bonds will have more p character, right? So these carbon-carbon bonds will have more p character. So as p character increases, the bond angle decreases, right? So as bond angle decreases, that is as bond angle decreases, so here the 60 degree will be obtained. So if this bond, that is the bond in front, will have more p character, that is the hybridized orbital sp3 one will having more p character, the opposite one present in the carbon-hydrogen bonds will have more s character, and we know that more s character means what? More s character means lesser bond length, lesser bond length. So lesser bond length means shortening of bond. So this is the reason. So let us summarize it together. Now see, the question is basically cyclopropane taken with H, and it is told that the bond length of carbon-hydrogen bond is much lesser than in case of a normal propane. Now normal propane we don't require to explain, but we require to explain the fact for this. So what is the fact? Since the bond angle is decreased from 109 degree 28 seconds to 60 degree, So we require these bonds to be made up of more p character. Why more p character? As we know, more p character means that less bond angle. Bond angle can decrease when p character is increased. So bond angle is decreased. So if these bonds have more p character, then the opposite bonds, that is here the formation, will have more s character, because as here the p character increases, the opposite orbitals will have more s character. So we know s character is proportional to 1 by bond length, that is inversely proportional. So as s character increases, bond length decreases, right? So as s character increases, bond length decreases. This means that this bond have length lesser than for these carbon hydrogen bonds. So this much for today. Thank you for watching. Do not forget to like, share, comment and subscribe.